The journey of powdered eggs begins at modern commercial egg farms where thousands of hens are housed in climate-controlled facilities designed for optimal egg production. In cage-free aviaries, hens move naturally across multi-level systems with integrated nesting boxes where they lay their eggs throughout the day. Automated collection belts running beneath these nesting areas gently gather freshly laid eggs and transport them to washing stations where rotating brushes and sanitizing sprays remove any surface contamination. After cleaning, the eggs undergo preliminary quality grading where automated sensors scan each one for cracks, defects, or irregularities that would make them unsuitable for processing. This initial sorting ensures that only the highest quality eggs move forward in the production chain, maintaining food safety standards from the very beginning of the manufacturing process.
A little more to the left. Keep it coming.
Okay, stop right there. Let's get this first pallet in.
Once collected, graded, and sanitized at the farm level, the eggs must be transported to specialized processing facilities equipped for large-scale egg breaking and dehydration operations. Workers carefully load plastic egg flats stacked on rolling carts into refrigerated transport trucks specifically designed to maintain optimal temperature during transit. These climate-controlled vehicles are essential for preserving egg quality and preventing bacterial growth during the journey from farm to factory. The refrigeration units mounted on the trucks continuously monitor and regulate internal temperatures while the vehicles travel along highways, often covering significant distances between rural egg production areas and urban or suburban processing centers. This critical logistics step maintains the cold chain that ensures the raw eggs arrive at the processing facility in peak condition, ready for the industrial transformation that will convert them from fragile fresh products into shelf-stable powdered ingredients. The egg-breaking stage represents the first major transformation in converting whole eggs into liquid form suitable for spray drying. Industrial egg-breaking machines process thousands of eggs per hour with remarkable precision, using mechanical systems that crack shells cleanly while separating the liquid contents from shell fragments. Each egg is individually cracked by automated mechanisms that have been engineered to minimize shell contamination in the liquid egg stream. For whole egg powder production, the yolks and whites flow together into collection systems, while operations producing specialized products may use centrifugal separators to divide yolks from whites for separate processing. The broken eggshells are automatically collected on dedicated conveyor systems and routed to waste processing areas where they may be dried and sold as agricultural supplements or calcium.
Tank 7 pressure holding steady at 20 psi.
Noted. Check the temperature sensor on line 4.
Before liquid eggs can be dried into powder form, they must undergo pasteurization to eliminate any potential pathogens while preserving the egg's functional properties for baking applications. The liquid egg is pumped from storage tanks through sophisticated plate heat exchangers, where precisely controlled heating rapidly raises the product temperature to levels that destroy harmful bacteria, including Salmonella. The most common method is high-temperature short-time pasteurization, where the liquid egg is held at specific temperatures for carefully timed intervals that achieve food safety objectives without overcooking the proteins. Digital monitoring systems continuously track temperatures at multiple points throughout the pasteurization process, with automated controls making real-time adjustments to maintain optimal conditions. After the heating and holding phases, the pasteurized liquid passes through cooling sections where plate heat exchangers rapidly reduce the temperature to prevent any protein coagulation that might occur if the product remained hot. This entire thermal process is carefully documented with chart recorders and digital logs that provide the traceability required by food safety regulations. The pasteurization stage is critical not only for safety, but also for meeting the stringent requirements of commercial bakeries that depend on pathogen-free ingredients in their production operations. After pasteurization, the liquid egg undergoes additional processing to ensure uniform quality and remove any remaining particulates that could affect the final powder's performance. Fine mesh filtration systems capture any shell fragments that may have escaped earlier removal stages, along with chalazi strands and other natural egg components that aren't desirable in the finished powder. The filtered liquid then passes through high-pressure homogenizers that break down fat globules and protein structures to create a completely uniform mixture at the molecular level. This homogenization process is essential for producing powder with consistent properties, ensuring that every spoonful reconstitutes identically when bakeries add it to their formulations. The pressure applied during homogenization can reach several thousand pounds per square inch. The spray drying stage represents the most critical and technologically sophisticated step in transforming liquid eggs into shelf-stable powder. Inside massive cylindrical drying towers that can rise several stories high, the homogenized liquid egg is pumped to the top of the chamber where high-pressure atomizing nozzles transform it into countless microscopic droplets, creating a fine mist that disperses throughout the tower. Simultaneously, carefully controlled hot air is introduced into the chamber, and as the tiny liquid droplets fall through this heated environment, moisture rapidly evaporates from their surfaces. The physics of spray drying relies on the enormous surface area created by atomization, which allows moisture removal to occur in just seconds as the droplets descend through the tower. The temperature, airflow, and droplet size must be precisely balanced to remove moisture quickly enough for efficiency, while preventing the protein from being damaged by excessive heat. As the droplets dry, they transform into fine powder particles that are carried by air currents to collection points at the tower's base and through cyclone separators that recover product from the exhaust airstream. Sophisticated control systems monitor dozens of parameters in real time.
To lower the powder moisture content, I'm increasing the atomization pressure slightly.
Confirmed. Throughput is steady.
The outlet temperature is fluctuating.
Adjusting the feed rate now.
Pressure is dropping, stabilizing the atomizer.
Immediately after exiting the spray dryer, the egg powder is still warm from the drying process and requires cooling to ambient temperature before it can be safely packaged. Fluid bed cooling systems provide the most efficient method for this temperature reduction, using upward-flowing ambient or chilled air that passes through a perforated plate, keeping the powder particles suspended in constant motion while heat is carried away. This fluidization creates the appearance of boiling liquid even though the material is solid powder, with the particles remaining separated and free-flowing as cooling progresses. Once cooled to room temperature, the powder moves to precision sifting equipment where circular vibrating screens with multiple mesh levels ensure particle size uniformity throughout the batch. This screening process catches any oversized particles or agglomerates that form during drying, diverting them for reprocessing while allowing properly sized powder to pass through to packaging. The sifting stage is essential for producing powder that will dissolve easily and completely when bakeries reconstitute it with water, preventing lumps or undissolved particles that could create quality issues in finished baked goods. After cooling and sifting, the powder collects in stainless steel hoppers where it awaits transfer to the packaging line, now possessing all the physical and functional characteristics required for commercial baking applications. Before any egg powder can be released for packaging and distribution, it must pass through comprehensive quality control testing that verifies both safety and functional performance. Laboratory technicians collect representative samples from each production batch and subject them to a battery of analytical tests in dedicated quality control laboratories adjacent to the production floor. Moisture content analysis is critical because powder with too much residual water will have shortened shelf life and increased risk of microbial growth, while excessive drying can damage proteins and reduce baking performance. Microbiological testing includes plating samples on culture media and incubating them to detect any surviving pathogens or spoilage organisms that might indicate problems with the pasteurization process or post-pasteurization contamination. Protein content analysis ensures the powder meets nutritional specifications, while functional property testing may include reconstitution trials, foaming capacity measurements, and even small-scale baking tests to confirm the powder will perform as expected in commercial applications.
bag count is correct. 3-ply egg powder.
Okay, seals match the manifest.
All right, drop it right there. Looks good.
Confirmed. Go ahead and strap it down.
Roger that. Securing the load.
Looks good. Go ahead and scan the master label. Confirmed. Inventory updated.
All right, let's see. 40 bags of egg powder. Temperature looks good.
Yes, everything is sealed correctly. Just sign here. We have 30 bags of egg powder, lot number 456.
Confirmed.
Okay, please sign right here for the delivery.